Greetings, space-time explorers. Welcome to Warp Drive Tech. I'm Todd Desiato, your trusty guide on this mind-bending journey through Einstein's field equations. Today we'll explore two captivating interpretations that could potentially unlock the enigma of quantum gravity. So buckle up and let's embark on this cosmic roller coaster. And if you're pumped for this adventure, don't forget to hit that like button and subscribe to our channel. First up, the traditional interpretation of the Einstein tensor. At the heart of Einstein's general theory of relativity are his field equations, which describe how matter and energy determine the curvature of space-time. This curvature is what we experience as gravity. Thanks to this perspective, we've unveiled some of the universe's most thrilling secrets like black holes, gravitational waves, and cosmic expansion. Now let's explore an alternative interpretation, where the Einstein tensor is seen not as a representation of space-time curvature, but as a description of the measurements obtained using rulers and clocks influenced by the distribution of matter and energy. This interpretation emphasizes the role of these measuring devices in understanding gravity and the geometry of space-time. Comparing these interpretations is like hopping between two parallel universes with the same underlying laws of physics. The mathematical framework remains the same, but our understanding of space-time and gravity shifts dramatically. The alternative interpretation brings a fresh perspective, focusing on the relationships between measurements made in the presence of matter and energy. These measurements ultimately dictate the cosmic choreography and geometrical relationships of objects in the universe. Hold on tight as we plunge into the exhilarating connection to the engineering model of quantum gravity that I've proposed. In this model, we delve into a world where gravitational fields are interpreted as variations in the driving power of the electromagnetic zero-point field. This power is linked to the coordinate speed of light and has exciting implications, such as explaining gravitational time dilation and length contraction as a loss of driving power from the zero-point field. As available power decreases, so does the coordinate speed of light, as if there is a radially decreasing refractive index surrounding planets, stars, and black holes. In this quantum gravity escapade, we uncover correlations between the observations used in general relativity and the relative radiative damping factor of the quantum mechanical harmonic oscillator. This factor affects our measuring devices, leading to variations in frequency and energy that give rise to what we perceive as space-time curvature in classical theory. As the damping factor varies, particles experience a slowing of frequency, making clocks run slower, and a contraction of mean square position fluctuation that determines length. This occurs because there's less available power to inflate matter to its proper scale, as observed by a distant observer in unaltered space-time. The power provided by the zero-point field source is radiated away by the damping of oscillations, explaining why gravity has a negative energy density. This energy deficit is the reason we need to do work to climb a hill. Just as in the general theory of relativity, the motion as well as the relative scale of matter is determined by the flow of energy and momentum into and out of the system volume. Matter falling into a gravity well is contracting and the oscillation loses power, whereas an anti-gravity warp drive would have the opposite effect on matter. Size would expand and clocks would run faster on board a warp starship. As we return from our epic voyage through the two interpretations of the Einstein tensor and their connection to the engineering model of quantum gravity, we've gained a thrilling new understanding of gravity and space-time. This alternative interpretation could potentially pave the way for a unified theory of quantum gravity, empowering engineers to unlock groundbreaking technologies like artificial gravity, anti-gravity, and warp drive. So what are your thoughts on these two interpretations of Einstein's field equations and their connection to the quantum gravity adventure? Let us know in the comments below. And if you enjoyed this wild ride through the cosmos, please give this video a thumbs up and subscribe. Warp Tech out.